let's do another lesson. This lesson is about factoring by GCF and factor by grouping. First, factoring by GCF, which stands for greatest common factor, is like undoing the distributive property. So you can see our first example here. We have a 2 and a 4. What goes into both 2 and 4? That would be a 2, right? It's pretty easy. So just like as if we were doing a distributive property, you would have a number on the outside. In this case, it's a 2 because 2 goes into 2x squared, and 2 goes into 4 2 times, right? And I know this is correct because if we redistributed this 2 back in here, we would get 2x squared, and then 2 times negative 2 would be negative 4, which is the original problem. Okay? So let's take a look at this example. In this example here, we have 3 terms. And all 3 of these terms have something in common, something that they all could be divided by. And they all could be divided by a 2, but we need the GCF. GCF stands for greatest common factor. There's a number higher than 2 that goes into all of these, and that would be a 4. Not just a 4, but also look, they all have at least 1x, right? So that should have been a square right there. So let's factor out a 4x, right? This has 3 x's, this has 2 x's, that has a 1x there. So let's factor out 4x. 4x goes into 8 2 times, but leaves x squared, right? Because we're taking 1 out. 4x goes into x squared and leaves just an x. And 4x goes into negative 16x and leaves negative 4. There we go. And like I said, we could always check this because we could redistribute back into the parentheses just to check it, right? This is the check. So we have 4x times 2x squared right here. And that's going to make 8x to the 3rd power. And 4x times x is negative 4x squared. And then 4x times negative 4 is negative 16x. And again, that's what we originally started with. Okay, let's take a look at, that was the check, this was the check here. Let's take a look at this next example right here. So if you notice, both of these have negative signs, so I could factor out a negative, right? Because they both have that in common. And I could factor out a 2, because 2 goes into both of these. That's the greatest number that goes into both 14 and 12. And they could also factor out an x, right? I believe that's the highest number of things I could factor out of both of these terms, negative 14x and negative 12x squared. So when I factor out negative 2x from 14, 2x goes into 14x 7 times. And it's positive now because the negative sign is on the outside here, right? And negative 2x goes into negative 12x squared and leaves positive, right? Because the negative sign again is on the outside. And that's going to be 6x. And if you're unsure of your answer, you could always redistribute your 2x back on the inside and check to see if it's correct, right? All right, let's try one more of these types of examples. Well, nothing goes into all of these, right? Nothing that I know of. So this is actually completely factored already. There's nothing we could do with that. There's no terms that go into all 3 of these, and you don't want to factor just 2 of these. That makes no sense. We could factor an x out there, but that doesn't make sense for this problem here. So we are going to leave this as completely factored. All right, let's take a look at this word problem here. The area of a court for the game of squash is 9x squared plus 6x meters squared. meter squared is a unit of measurement, right? Area. It's actually not part of the polynomial. And the problem says, factor this polynomial to find the possible expressions for the dimensions of the squash of court. Dimensions, right, for a game of squash is length times width, area of a rectangle. So we got 9x squared plus 6x meters squared. What number goes into both 9 and 6? 3, right? And you can see that they both have an x, right? This first one has x squared. So this is going to be 3x plus, and 3 goes into 6 2 times. I'm going to put the x out here. All right, so, and that's meters squared. So this first term right here, I'm just going to call this the length. Not that it really matters which is which. And this term here is going to be the width, which is 3x plus 2. There we go. All right, let's take a look at the next examples we have down here. This is when we're going to get into the factor by grouping. Look at this factor by grouping problem. As you can see, we have two binomials, and they are both the same. And we can factor out the entire binomial, like I said, as long as these two binomials are the same. So that would become x plus 2. And then in the second parenthesis is going to be 5 plus 3x. Let me show you an example of why this is. Let's say we had 5y plus 3x times y. What could you factor out of each one of these? You can see right here we have a y, right? Both terms. So we could factor that y out. And where would you put it? In front of the parentheses. And in here would be 5 plus 3x, right? Just like the problems we did at the beginning of this section. And that's the same. This y is much like x, just like this first binomial here, because it's what's in common, right? It's what's in common. The y's were in common. So you were to factor them out. All right, so let's take a look at this one. B. You can see in both binomials are exactly the same. So b squared plus 1, and then b squared plus 1 in the second one. There's no number here in front of the second one, so let's just put a 1, because you can multiply 1 times anything. So let me factor out that b plus 1, b squared plus 1, and the second parentheses is going to be negative 2b. Remember, this slides in the second parentheses, plus 1. And there we go. We're done. You could factor out a negative sign in the second one if you want, but we'll just leave it like that. It's factored. All right, let's take a look at this one. Here we have two binomials. Look at these binomials. I said in previous examples that these binomials need to be identical, and as you can see, they are not. So this is completely factored. I'm writing this so this way the person that looks at my work knows that I know it's already done. If you leave a problem like this blank, I can imagine that your professor or teacher would assume that you do not know whether it's factored completely or not. All right, let's take a look at this. This is where we're finally getting to the factor by grouping. The reason why this is all called factor by grouping is because we actually are going to group some parts together. So let's factor out a 2 goes into both of these, right? 2h to the third power, 2h to the third. 2 goes into 6 3 times, and there's one h left over there. 2 goes into 4 twice, and since we factored out all 3 h's, there's no h left over there. In the second parentheses, we could factor out a 4, right? 4 goes into 12 and 8. So that's going to be 4 goes into 12 3 times. That's 3h. And 4 goes into 8 twice. Now, let's take a look at these, right? We're not done yet because now our binomials, just like in the previous examples up here, right? They're identical. In the same situation here, they're identical, 3h minus 2, 3h minus 2. We could factor out that 3h minus 2, and in the second parentheses is going to be 2h to the third power plus 4. All right. Unfortunately, we still have more work, right? Look at this second parentheses. There's a number that goes into both of those. And that number is a 2, right? 2 goes into 2, 2 goes into 4. So let's factor that out. 2, 3h minus 2. And this parentheses is going to be h to the third plus 2. Sheesh. Finally done, right? So you may have noticed that I actually put the 2 all the way in the front. I just did that because you can write multiplication in any order. This is just typically how you do it. This is how you'll see it in textbooks. This is how you'll see professors write it, so on and so forth. You can, however, write it this way if you like. H to the third plus 2. You can write it like that. It's just typically not done that way. The reason why is because multiplication is commutative, right? Commutative means 3 times 2, or is the same thing as 2 times 3, right? It's the same answer. Regardless how you multiply it, you still get the same answer. Multiplication is commutative. It has the commutative property. You multiply in any order. But this is how us math teachers and professors normally write this. All right, let's take a look at this one. Let's see, we got a couple more examples here. Let me go back to the blue. Grouping. First parentheses, I see we could take a 5, and what else? They both have a y. How many y's? Looks like we could take 3 away from both. If I take 5y to the third away from the first term here, I'm left with y. If I take 5y to the third away from 15y to the third, that leaves me with 3. Let's take a look at the second parentheses here. I can factor out a y. And if I take a y out, that leaves me with y, because there's 2 there. There's 1, there's another, minus 3. Not done yet, right? So we have identical binomials, which can be factored out, which is going to be y minus 3. And the second parenthesis is going to be 5y to the third. That's this, plus y. Still can factor something out, right? Take a look at this parentheses. We can factor out a y. So it's going to be y minus 3. And if I take a y away from this, it's going to be squared. If I take a y away from this one, it leaves me with 1. There we go. That is the answer. Completely factored. Move on to this one. Now this is getting a little tricky here. So factor by grouping. We got a group. What can we factor out of this in this one, right? What can you factor out of these? 2x squared. If I do that, that leaves me with an x minus 6 plus, what can you factor out of this one? 3 goes into both of those, right? 6 minus x. Now, at this point, I've been saying that we had identical binomials, but we do not this time. X minus 6, this one is not the same as 6 minus x. These are not the same, so we have to do something to make them the same. They have all the same parts, an x and a minus sign and a 6, right? And this has a 6 minus sign and an x. We could do something about that. And this is it, right? Let me show you. This is going to be x minus 6 plus 3. I'm going to switch these two terms around. So the 6 is going to be over here. That's a positive 6. And the negative x over there. Okay, now once I've done that, I need to change these signs. These signs right here, this negative and this positive, I need to switch. So this way the x is positive and the 6 is negative. And this is how you do that. We can factor out a negative sign. 2x squared. Everything else is going to stay the same, except now there's a minus sign here, right? And what that does is it changes this x to a positive and changes this 6 to a negative. And now if you look at our terms, now they're identical, right? X minus 6. So let's factor out that x minus 6. X minus 6, and then we got 2x squared minus 3. Whoo-wee! That's done. That is completely factored. There's nothing else we can do there. Okay, let's take a look at this last example. I got a little quiz for you coming up at the end here. So, remember this is called factor by grouping. So that's what we're going to do. Group, 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 group. So in this first parentheses, we can factor out a 5, right? 5 goes into 15 and 10. And we can factor out x to the second power. Now this has 3 x's, and this is x squared. So the highest number of x's we can factor out is x squared. 5 goes into 15 3 times, and 5 goes into 10 twice. But there's 1 x left over right there. For this term, for this parentheses, we can factor out a 4. 4 goes into both 8 and 12. 4 goes into 8 twice, and 4 goes into 12 3 times. All right, so you can see that these parentheses here are not the same. They're similar, though. They have all the same parts. They both have a 2x, they both have a 3, and they both have a minus sign. Because of that, we can make them look the same, as I said in the last example. I'm going to change this first one to look like the second one over there. So 5x squared, and I'm going to flip these two terms around. That's a positive 3 plus 4. The sign that's in front of the 2 goes with it, right? So you can see it's a minus 2x. 2x minus 3 in the second parentheses. So there's one other thing I need to do, right? I need to get these, let's see here. There's a minus sign here, there's a plus there. There's a plus here, and there's a minus there. So what I can do is I can factor out a negative 1 on the outside here. So it's going to make this 5 become negative. And then this 2x becomes positive 2x, and that 3 becomes negative 3. Plus 4, 2x minus 3. All right, so let me come back and take a look at these. They are the same, right? 2x minus 3, 2x minus 3. So I can factor that out, and this is going to be 2x minus 3 parentheses, and then in the second term will be negative 5x squared plus 4. And then sometimes you just want to look at it for a second and think, is there anything else I could factor out? There isn't. This is completely factored. Done. All right, so the next thing I have is the lesson quiz. Folks, here goes the lesson quiz. So you could pause the video here, write these problems down, and give them a shot. See how you do. In about 5 seconds, I'm going to put out the answers so this way you can check your work. Good luck. All right, folks, so here are the answers to the quiz. See how you did. If there's something wrong, take a look at your work. Make sure everything is completely factored. Until next time, don't forget, the best way to get better at math is by actually doing math. Peace.